Dear students, welcome to the online class for the subject Renewable Energy Resources. This is the continuation of lecture number 33, Ocean Thermal Energy Conversion System. In open cycle ocean thermal energy conversion system, the seawater itself is used to provide the thermodynamic fluid. Warm seawater is expanded rapidly in a partially evacuated chamber where some of it flashes to steam. The steam is then used to drive a steam turbine. From the exhaust of the turbine, the vapor is condensed using cold seawater. The vapor produced by flashing warm seawater is at a relatively low pressure, so it requires a very large turbine to operate effectively. So, advantages of open cycle and thermal energy conversion system. So, one of the major advantage of the open cycle system is that the water condensed from the turbine exhaust is fresh, not salt water, and so the plant can also serve as a source of drinking water as well as electricity. A 210 kilowatt open cycle ocean thermal energy conversion pilot plant operated in Hawaii between 1993 and 1998. Disadvantages of open cycle ocean thermal energy conversion system. Practical limitations means that the largest open cycle turbine that can be built today is around 2.5 megawatt, much smaller than for a closed cycle system. This is closed cycle system pictorial representation. So 26 degrees centigrade warm surface water has been given to the evaporator. So that has been given to 26 degrees centigrade warm surface water has been given to evaporator. And the output of the evaporator is 23 degrees centigrade exhaust water. So this exhaust water has been given to turbine to generate the mechanical energy. So from the mechanical energy output of the turbine has been fed into the generator. So mechanical energy has been converted into electrical energy. So the 6 degrees centigrade cold deep seawater has been given to the condenser. That has been flown to the feed pump. So inside that ammonia liquid has been filled. This is closed cycle open thermal energy conversion system. So from working fluid vapor has been fed into the turbo generator. The output of the turbo generator, that is working fluid vapor, again has been given to condenser. Then from the condenser to working fluid concentrate to draft tube. Then working fluid again has been fed into the evaporator. Then from the evaporator, warm water has been fed into the evaporator, and the output of the evaporator return water to sea level. So the condensed output has been again returned to sea water. The input is nothing but cold water. A closed cycle open thermal energy conversion plant employs a thermodynamic fluid such as ammonia or refrigerant like freon. This is contained in a completely closed system including the plant turbine. Hot surface seawater is used to evaporate the fluid, and the vapor is then exploited to drive the turbine. The vapor from the turbine exhaust is condensed using the cold deep ocean water and returned to the beginning of the cycle where it can be reheated. This is nothing but a hybrid cycle, combinations of both open and closed loop cycle system. So it is having a main eliminator So the chamber is nothing but an ammonia evaporator, that is preheater and boiler has been fitted inside that. So this is NH3 vapors. It is at the pressure of 890 kPa, that is at the temperature of 21.1 degrees C and 274 kg per second. And turbine has been given the efficiency of about 80%. From the turbine, generator generates 7920 kilowatt gross, 5260 kilowatt net without water cycle. So the output of the turbine is 11.9 degrees C, 656 kPa pressure that has been fed into the ammonia condenser. So again that pressure has been reduced to 642 kPa and it has been increased to feed pump, that is 915 kPa, that has been fed into the ammonia evaporator. It is a clean and pollution free renewable source of energy. This is the major advantage. So power generated by the system is continuous. Only a small variation in output takes place from season to season. In simple words, we can say the system is independent of weather. By making only small changes in design, conventional power plants can be used in this system. It can produce the desalinated water and nutrients for mariculture at the same time. The capital cost is very high. This is the disadvantage of the OTEC. The overall efficiency of the system is very low. The open cycle system needs very large size turbine due to the low pressure of steam. In the closed cycle system, the working fluid is very expensive. The cost of power generation per kilowatt hour is very high. Thank you.